All right, good morning, everybody. For today, we're taking a look at solving multi-step inequalities and then, of course, graphing the solutions. So this is day 3 in our Schoology course, part A. Tomorrow will be part B, where you'll be asked to do a little review activity. Our essential question today is, how do I solve multi-step inequalities? At any point during this video, I would certainly encourage you to pause when needed and copy things into your notebook. Okay, you still want to take notes even when it's from an ed puzzle. All right, so first thing, we have multi-step inequalities. Just a couple of reminders. Anytime you solve multi-step inequalities, as we would with multi-step equations, we still want to use inverse operations when solving. So to undo adding, you want to subtract. To undo multiplication, you want to divide, and so on. We also want to work backwards. If there's ever more than one step or one thing that you need to do, we always make sure that we follow SADMAP, which is the reverse order of operations, when we're solving equations. And then remember, reverse the inequality rule we talked about on day 2 yesterday for most of you. If you multiply or divide by a negative number on both sides when you're solving, you have to reverse the inequality rule because it changes which side has the larger value. So keep these things in mind as we're solving multi-step inequalities today. Here's our first example. So here we have a fraction on the left-hand side. It just says m plus 5 divided by negative 3 is greater than or equal to negative 4. And I have the steps listed there on the bottom right-hand side of your screen. This is what we're going to do. So we're going to start by undoing the division. Because keep in mind, this m plus 5 is kind of grouped together in the numerator. So the first thing we have to do is try to get rid of that negative 3. Okay, so we have to think, how is m plus 5 attached to the negative 3? It's through division. And to undo division, we want to go ahead and multiply both sides by negative 3. So negative 3 times that fraction, and then multiply by negative 3 on the other side as well. So let's see what we get. On the left-hand side, our negative 3 is going to cancel with that other negative 3 because the multiplication undoes the division. And that's going to leave us with m plus 5. And on the other side, multiplying two negatives will result in a positive number. So we get positive 12. Now notice in our rule, or in our work here, we multiplied both sides by a negative number. So we have to go ahead and reverse the inequality symbol to be less than or equal to. And we do it right there because that's where we divide or multiply both sides by a negative number. Now we finish solving. M's not by itself yet, so we got to keep going. To undo the plus 5, we subtract 5. And we'll get m. Let's see, I would do the subtract there, so leave the inequality symbol the same. M is less than or equal to 7. So on my number line, I number 6, 7, 8, so that my boundary is in the middle. I want to make a filled-in circle because 7 is actually a solution here. That would make this true. 7 is less than or equal to 7. And then all the other numbers that are less than or equal to 7 would be to the left, like 6, 5, 4, 3, 2, 1, and so on. Those are all numbers that are less than 7. And of course, 7 is equal to 7. I would take a moment to pause if you need to and update your notes before moving on to example 2. All right, here's our second example. 7n minus 1 is greater than negative 169. So I want you to think about, what would you do first in solving this inequality? All right, well, hopefully you said add 1 on each side when you responded in the ed puzzle question. So we add 1 on each side. That's going to leave us with 7n and negative 168, because remember, we're starting with the negative 169 and bringing it back, positive 1. And next, what do you think we're going to do next? All right, and again, hopefully you said here that this time we're going to divide by 7 on each side. And when I divide, I get n. I get negative 24. Now here's the big question. You're going to have to answer this in Edpuzzle. Should I flip the inequality symbol? We do not flip the inequality symbol here. We didn't divide by a negative on both sides, and it's this number that you're looking at, the number that you write on both sides. That's a positive 7. So the rule here is we divide by a positive 7 on both sides, so you do not flip the inequality symbol. So I draw my number line, remembering I'm on the negative side, so they kind of go backwards. I have an open circle at negative 24, and I want everything greater than negative 24 to represent my solution. So that's going to be to the right. And again, if you need to pause at this time to update your notes, I would encourage you to do so. All right, here's number 3. Solve this multi-step inequality. This time I notice I have variable terms on both sides. So I have a variable term, constant term, variable term. What I need to do is have to try to sort these and balance it out. I have to get the variable terms on one side and the constant terms on the other side. So when I look at my steps down below, simplify each side, it's already done. Next, I want to combine my variables, and I prefer to do this on the left side with inequalities because that's how I want it written when I graph the solutions. So I'm going to start by subtracting 8a from each side. And I remember that the a that I began with was 1a, the coefficient of 1. So 1a minus 8a is negative 7a. My inequality symbol stays the same because all we're doing there is subtracting. Next, I want to get the constant terms to the other side, to the right side. So I'm going to add 6 to move that minus 6. And that's going to leave me with negative 7a is less than or equal to 21. And I don't change the inequality symbol when I add 6 to both sides. All right, so our next step, let's see, I got to get rid of the negative 7. So let's see, combine variables, combine constant terms, divide to solve. I'm going to divide by negative 7 to solve my inequality. It's going to leave me with a on the left, negative 3 on the right, and do I flip the inequality symbol? This time I do flip the inequality symbol because I had to divide by a negative number on both sides. For our graph, negative 3, negative 2, to the left would be negative 4. Would I draw an open or a closed circle for this inequality? I would draw a closed circle for this inequality because negative 3 is a possible solution. Now, my inequality says that it's also not just equal to negative 3, but any number greater than negative 3. So do I want to draw my arrow to the left or to the right? Everything greater than negative 3 will be to the right of it. So a is greater than or equal to negative 3 as our solution. Take a moment to pause and update your notes. Final example. 28 minus k is greater than or equal to 7 times k minus 4. Now here we see right away that there are some parentheses on the right-hand side. We have to do a little multiplication. So our first step of simplifying each side is really nothing we can do on the left side, other than maybe, I could write it as 1k because that might make things easier later. But I can also distribute on the right. 7 times k, 7 times 4. So there's my new inequality. Now I'm ready to start rearranging and moving things around. So next I want to combine variables, and my preference is always to move things to the left-hand side, for the variables at least. So a positive 7k, I want to subtract 7k to move those to the left-hand side. And let's see, that's going to leave me with 28 minus, let's see, that's 8k. That zeroes out. Let's bring down the negative 28. And all I did was subtract, so my symbol stays the same for now at least. All right, so I move my variables to the left. Next, I want to move my constant terms to the right side. So I have to move this positive 28 over by this negative 28. So I take away 28 from each side. 28 minus 28 is 0. 0 minus 8k is negative 8k. Oh boy, negative 28 and negative 28, that's negative 56. And all I did was subtract again, so my inequality symbol stays the same. Then, our final step is to divide by negative 8 to solve. I get k by itself. I get, let's see, 56 divided by 8 is 7. When you divide two negatives, you get a positive. So then the big question is, do I flip the inequality symbol? Yes, we do. Absolutely. Anytime you multiply or divide both sides by a negative number, you flip the inequality symbol. So our final answer, k is less than or equal to 7. So on my number line, I'm on the positive side, so they go in order from least to greatest like that, 6, 7, 8. Should I draw an open or a closed circle? I should draw a closed circle because the inequality has a line underneath it. Then, or the inequality symbol has a line under it. Then, because my inequality symbol is the less than variety, should I draw my arrow to the left or to the right? I do want to draw it to the left for less than. So k is less than or equal to 7 would include solutions like 7, 6, 5, 4, 3, 2, 1, 0, and all the negative numbers. Take a moment to pause if you need to and update your notes. All right, the rest of the time should be spent working on the practice assignment. You can find that in Schoology. It'll open up in Kami, and I believe there are just 6 problems to take a look at today. Thanks for listening. Bye.